And moreover, the rate of aging increases as the magnitude of this imbalance increases. Thus, by enhancing protective and repair processes, I feel hormesis should act to slow the rate of aging. And so, to me, it fits very beautifully also as an anti-aging factor because of its hormetic action. Okay, next slide, please. Now, I think this is bolstered from a series of things. First place, we do know that you can get, not with the kind of magnitude that you see with caloric restriction, but you can get other low-intensity stressors to extend life. That's been seen with heat in 3 organisms, true non-mammalian. It's been seen with hypergravity in the fly and osmotic stress in yeast. So I think that indeed this is supportive evidence for the hormesis hypothesis. Have the next slide, please. And also these genetic studies that extend life also add to my feeling that hormesis probably is involved there too. And the reason for that is that these long-lived mutants of these non-vertebrate animals, or yeast and non-vertebrate animals, have increased resistance to stressors, as you can see there. So we see that not only caloric restriction, which extends life, is able to have this relationship to increasing resistance to stressors, but also that many, not all, but many of the genetic manipulations do as well. Now, I think the real problem here is, it's great to say this, it's certainly got tremendous amount of evidence that it's probably true, but it lacks one tremendously important thing, and that is, what's the pathway? I mean, I'm saying hormesis, but what is the pathway? And that has not been defined. As a matter of fact, I was very enthused a few years ago by Dr. David Sinclair's work. Next slide, please. And this is why I was impressed, was that he had evidence, basically, that caloric restriction, like 2 other moderate stressors, increased this particular neuraminidase, which then was able to lower the nicotinamide level, enabling the deacetylase activity, or deacetylase activity of SIR2 to increase, and then through an efferent limb that he really didn't define at the time, led to life extension. And I thought, boy, this is great. This is the kind of thing we need, and all we have to do now is to pick up these question marks. Well, I've been a little disillusioned with this as the time has gone on. I mean, this would be great if it were generally true. First place, he tried to fill this in, and I was unimpressed. What he said was that it worked by decreasing apoptosis. And I have a lot of problem with that, because the apoptosis theories are really wild. One group says that caloric restriction works because it downregulates apoptosis, and another group says it works because it upregulates apoptosis. Yes?
But that's because they're looking at mitotic and post-mitotic tissues and organisms.
Yeah.
Yeah,
But
so.
nevertheless, I think we have very little evidence. Get back to here.
We
have very little evidence that a loss of cell number, for instance, and that's what basically Sinclair was claiming, that a loss of cell number is a major problem in aging. Now, it may be, but we don't have the evidence for that yet. But I agree with you but the whole apoptosis story is very complicated, and I don't think it relieves these question marks. I presume you don't either. Yeah, right, okay, right.
I mean, yes, I do.
Okay, well, we haven't worked out the pathway, but I think indeed we have certain kinds of clues. If I could have the next slide, please. And also another possible mechanism underlying this protection is that caloric restriction increases and maintains the ability to induce heat shock proteins. And I'm just going to go over HSP70, but these are a broad range of proteins and by which it could work. And I'm only giving my colleague Arlen Richardson's data because he's my colleague, but others have done work here too. Next slide, please. And what Arlen has found, of course, is that with age, there is a loss in the ability to induce this in response to a heat stress. And what he finds is that at all ages, the dietary restriction animal is able to induce it more. And indeed, even when they're old, and these are quite old, for fisher rats, these are very, very old, they're still at the level of the young ad lib. So this is certainly one of the areas where indeed we may be able to build that hormesis pathway. Have the next slide, please. Now, it also enhances the repair process and may also be able to, and that may also be a component of the hormetic pathway. For instance, it enhances the ability to repair the transcribed strands of DNA in rats. It enhances the rate of whole body protein turnover. So indeed, as proteins get damaged from things like oxidative stress, the fact that you can turn them over more quickly means that you're going to repair the thing. So I think that we have good pieces of evidence of how hormesis might work, but at this stage, we have not defined a given pathway, and it may be a complicated multiple pathway. And indeed, as a mammalian physiologist, I wonder indeed if we haven't discovered one of the mechanisms just by looking for whether or not caloric restriction was a stressor. And the next slide, please. Oh, I'm sorry. Before the next slide, I should go over with you that, as you saw in the early slide, what we were seeing was an elevation of glucocorticoids. Now, in the physiological literature, it has long been known that glucocorticoids like corticosterone or cortisol are very important in protecting the animal from damage. And indeed, I was quite interested in this work of Pashko and Schwartz, in which they saw that caloric restriction had ability to protect the mice against chemically induced tumors, but that this is lost if you adrenalectomize the animal. Now, Schwartz and Pascoe have never shown that it's the glucocorticoid component that's important, and that should have been done, but they never have done that. But nevertheless, it implies that indeed, from an organismic point of view, the caloric restriction may well bring out a generalized organismic defense mechanism, namely an endocrine system that is bringing about defense. Okay.